Hi, so welcome to the last video from the fourth lecture, and this one is about data visualizations using histograms, box plots, and scatter plots. So I would like to base all the examples on primarily collected data from my own research. And before we start, I will introduce you to the topic really briefly. So the idea is like this. Respondents took part in a thought experiment and they were asked to vote for distribution of public health care funds for two cancer patients. So those groups were of the equal size, and one group consisted of people who never smoked, and the second group consisted of people who used to be smokers. So here people were to decide what proportion in percentage of public health care funds to allocate for the group of former smokers. So actually in this experiment I analyzed the role of causality biases, and later on you will see why it's gonna be important. So then respondents were to provide some estimated value for the ratio of people who have the cancer because they smoke out of the total number of cancer cases. So this measure is treated as the perceived probability of getting cancer because of smoking. It's like causal contribution of smoking to developing cancer. And finally, in the last round, people were displayed some information about determinants of cancer other than smoking, and they got a chance to reconsider their decision about the distribution of public health care funds in the light of new information. So that's it. I mean, everything you need to know about the setting in order to be able to interpret the data. So as a result, I got several variables, which were proportion of funds allocated to the group of former smokers in the first round and in the third round, and also perceived probability of getting cancer because of smoking, something like this. So now, when we keep this in mind, I'm going to show you what techniques for data visualization you can use in order to get some useful representation of your data, and also how you can interpret those graphs. And we shall start with histograms. So this is the distribution of funds assigned to the group of former smokers in the first round. And when we discuss histograms, we can discuss absolute or relative frequency, but I am more interested in relative frequency. So what proportion of people assigned this particular proportion of funds to the group of former smokers in the first round? So this is the value of variable. So it was not specified as the discrete variable, but I believe there is something about human mind. Like we like round numbers more than not that nice round numbers. That's why most of people chose like 20, 25, 30, 40, 50, and so on and so forth. So here you can notice that 80 is the maximum value of this variable. So there was no single person which would give former smokers more than 80% of the public health care funds. Here you can see that most of people, slightly less than 40% of people, gave 50% to the group of former smokers. So this value has the highest frequency. So then the second largest is 30%, slightly more than 15% of people, and so on and so forth. So this is the idea behind any histogram. It gives you some idea about the frequency featuring certain value in the sample, like this one, for instance. So slightly less than 15% of people assigned 40% of public healthcare funds to the group of former smokers. This is how you interpret it. Also, looking at the histogram, you get pretty nice idea about the distribution of the variable. So you can definitely see that more people gave less than 50% compared to the number of people who gave more than 50%. And in fact, 50% appears to be the most popular choice in the sample. I can compute the second histogram for comparing, the results for the first and the third round. And actually, I can see that after reading some information about determinants of cancer, even less people decided to give 50%, which was quite surprising for me. But again, this is what we do when we analyze the data. You let the data speak. And also, I can notice that more people gave less than 50% compared to the first round, because here it is, and here it is. So this distribution is still not symmetrical. Unfortunately, the number of observations is not sufficient to design the nice continuous distribution. Also, most of people were really likely to get some round numbers, again like 40 or 50. So that's why we have those gaps. But yeah, nevertheless, histogram is quite a useful instrument for applied data analysis. Strongly recommend. So now we proceed to box plots. And this is the typical representation of the box plot. So in this case, I wanted to analyze whether there is any difference in the proportion of public healthcare funds assigned to former smokers among the respondents who are non-smokers and respondents who smoke or used to smoke. So actually here, when you analyze box plot, typically you have minimum possible value. Here you have maximum possible value, 80%, because as I told you, no one assigned more than 80% to the group of former smokers. So here you have mean value, maximum value, and minimum value. So first of all, we can conclude that among smokers, mean value assigned to the group of former smokers is bigger than in the group of non-smokers. So people who also have this habit tend to be more sympathetic to the patients who used to smoke. Yeah, so again, here box plots can give you some initial idea about distribution. So on one graph, you have information about mean value, maximum value, and minimum value. And sometimes you also have some outliers above or below the box plots. So those are values which are radically different from the values in the sample. But in this case, it was not the case. That's why we cannot see any outliers on the graph. Unfortunately, you cannot compute box plot in Gretel. For this, I used R software. But yeah, nevertheless, if you would like to use them as well, I can share the code with you. Nothing that complicated. And finally, we proceed to scatter plots. In case of scatter plot, you simply put the value of one variable on horizontal axis, let's say, the value of the other variable on vertical axis, and you put all the observations on the plot. So this one was computed in Gretel. That's why you can also see the regression line, because there is a strong positive relationship between those two variables. So people who gave more to former smokers in the first round also tend to give more to former smokers in the third round. But yeah, scatter plots are useful for getting some initial idea about correlation between two variables, as well as the shape of the strand. So here, yeah, you can definitely see it. Okay, so that was it when it comes to data representation. Of course, there are much more possible options, but here I just wanted to concentrate on the most common and non-trivial ones because I believe it wouldn't be a problem for you to design a pie chart, let's say. So thank you for your attention and see you in the next lecture.